předpokládám a doufám, že jsou tady i nějací neswift vývojáři, kteří si chtějí poslechnout o Swift Package Manageru. A přednášet bude Honza Dvorský, který je vlastně se podílel například na vývoji aplikace SwiftKey pro iOS, což je jedna z nejpopulárnějších nebo snad nejpopulárnější klávesnice třetí strany na iPhoneu. Je to velký fanda a přispěvatel do open sourceu a jak už bylo zmíněno dneska předem, tak v pondělí nastupuje do Applu, kde se bude starat o vývojářské nástroje. To mi myslím jako představení stačí, myslím, že Honza si ještě doplní sám, co si myslí, že je potřeba zmínit a teď už mu předám slovo a děkuji, že jsem přišel na mDevTalk dát nějakou zajímavou přednášku o Swift Package Manageru.
So hi, welcome everyone. Welcome to mDevTalk. My name is Honza Dvorský. You might know me from Twitter and GitHub as Checkboy0. I studied robotics at FEL, at ČVUT, at this school, and then I moved to London where I worked at SwiftKey for 2 years. Then I studied a master's degree there at King's College, and now, as was mentioned, I'm joining Apple next week to work on developer tools. So that's enough about me. And about this talk. So there will be links like this, so you can click those once you get the PDF. If you get it, I already tweeted the link to these slides. And they're also on my website, so either on Twitter or the website, so you can get those. So how many of you are iOS or Mac developers here? Okay, great. How many are Android developers? All right, nice. Because I have something for everyone, hopefully. But still, I'll do a quick introduction into Swift first. So, Swift was created by Apple. It's a new programming language. It was announced in June 2014 at WWDC. Then it was open sourced less than a year ago in December 2015. And a big milestone was Swift 3.0 that came out this month. So together with the Swift project, with the open sourcing of the Swift project, Apple also announced and open sourced the Swift Package Manager. You can abbreviate it as Swift PM, but keep the spelling because there was a lot of flame wars about the right spelling. Today I'll try to introduce you to it. I'll try to show off some of its features. And one more show of hands. How many of you used the Swift Package Manager before? All right. Not many, that's good. So hopefully you'll take something away from this talk. So this talk will be useful for iOS and Mac developers when it comes to Swift and Swift Package Manager. But also potentially to backend developers because Swift already runs on Linux and maybe something for Android developers later as well. So as mentioned, iOS developers, backend developers, even Android developers. Or in general, if you're interested in what Apple thinks a programming language should look like today. So today, I'll try to do the introduction, and we'll do a demo. We'll create a couple of packages. We'll do some compiling and running. And then I'll get into more advanced topics when it comes to packaging. So let's start at the beginning. What is Swift Package Manager? Apple defines it as a tool for managing the distribution of Swift code, and it's integrated into the Swift build system to automate the tasks of downloading, compiling, and linking dependencies. So classic. Excuse me. Sorry, I have a cold, so if you can hear that, I apologize. So Swift Package Manager is a dependency manager. It's a build tool. And it's also a test tool. So it's not 3 separate tools, it's just one thing. It's command line based, so you need to know a little bit of that to use it right now. It is cross-platform. It runs on Mac OS and Linux, and potentially more platforms as we go on. It is decentralized right now, so there's no one central index, like in the case of CocoaPods. It's very opinionated, as most things from Apple. And it prefers convention over configuration. So instead of to write big manifest files, it tries to understand from how you structure your code what you mean. You can read about it and learn more about it a couple places. The most important one is swift.org/package manager. That's the official page with documentation and examples. You can look at the source code, and I would definitely recommend that because it's a lot of very nice Swift code written by people inside and outside of Apple. So if you want to look at Swift code, that's a very good place. You can join the mailing list, so you can see how people discuss all new features, changes, and so on. And you can even join the Slack. So there's a Slack where there are Apple engineers and people from the community talking together, and you can just ask for quick help if you just go there. So Swift Package Manager. What is that package in there? A package is basically a folder that has a package.swift file, and then it has some other source files. It contains something called modules. So modules are things that get compiled into something. And this is the simplest top-level structure of a package. So you just have a manifest file called package.swift, then you have a sources folder, and then you can have a tests folder, which I definitely recommend, but it's not required. As I mentioned, a module is basically just a collection of source files. So, your Swift files in this case. And, there's some implied build instructions. So, for example, here's a folder, build these files as a library. So, example of modules, so foundation is a module, XCTest is a module, dispatch is a module. And all of those are, for example, library modules. An example package is, I have a very simple package called environment. It just allows you Swifty access to environment variables. And that contains two modules, a library module and a test module. So this is what it looks like, the structure of it. It has the top level package.swift file. It has a sources folder. It has tests folder, and the files are contained in it. This is environment's package.swift file. And note one thing. I mentioned that we have one module here, and there's a test module here, but the package.swift file doesn't specify that. And that's what I meant by convention over configuration. If you just structure your files in this way, Swift Package Manager understands that you mean to build a library module and a test module, so you can just say what the name is, and you don't need to specify the name of the targets, where their source files are placed, and so on, like you have to in the case of CocoaPods, for example. Now, you might ask, I already use CocoaPods or Carthage. Is this just another dependency manager? Well, yes and no. So it's a dependency manager plus a build and a test tool. So you can think of it as if you took CocoaPods and you combined it with Xcode build on the command line. That's probably the closest analogy I can draw. But the advantage here is that it does not depend on Xcode, and thus, you can use it on multiple platforms. That's a huge advantage. Sorry. You might say, I already support CocoaPods. How can I support Swift PM easily? Well, you're in luck, because Boris Buechling made a tool that actually takes a CocoaPods pod spec and it tries to generate the Swift package manifest, the package.swift file. So it can be helpful. Can be a helpful starting point for your projects. But if we get more philosophical, why should you support Swift PM? It's just a new dependency manager. Well, if we look at the current Swift PM adopters, there's already over 3,500 Swift PM packages on GitHub, and these are only open source ones. So there are many, many more that people are creating and using in their privates. You can look at these stats. I actually maintain these stats. Well, not anymore. I handed them over. But there are stats that I crawled from GitHub, and then just looked at what's in there, and that's how we got the 3500, and it grows about 30, 40 every single day. And a big group of people that started using SwiftPM is the server-side Swift community, which I'll talk about more later today as well. But for you, it might be useful if you have any models, model layers of your app written in Swift, any parsers that working, the low-level stuff, the non-UI or the non-platform specific stuff. And these are the big advantage that if you're writing your code against Foundation, XCTest, and Dispatch, all of those are already available on Linux as well. So you can write your servers and stuff against Foundation, XCTest, and Dispatch. But since we have some Android developers here today, I also want to have something for them. I did some research about the state of Swift on Android, and actually Android already supports Swift now. So there was a pull request in Apple Swift that merged the Android support. So you can already write, to a certain extent, some code for Android that is written in Swift. This second link might be useful if you're actually interested. So this is getting started with Swift on Android. This is official documentation. And there's also about 3 blog posts from people at one company that tell us about how they actually got a Swift app on the Play Store. So there already is at least one Android app written in Swift. And there were some rumors about Google actually considering, better support for Swift because, it's a great language in my opinion. So if they make it easier for people to write, like in C++, write one model layer and just share it across platforms, that's probably better for everyone. So if you do want to give it a try, if you have Xcode 8, you already have Swift Package Manager. It's distributed as part of the Swift toolchains, and the Swift 3.0 toolchains already contain the Swift Package Manager. You can download those directly, and that's very useful. Well, that was very useful between January and now, when every 2 weeks there was a new snapshot of the Swift Package Manager, of the Swift language and stuff towards the Swift 3.0 release. And you can use this tool called SwiftEnv, which you might know similar tools from different languages. So this allows you to switch between different Swift versions for different projects. So you just have a hidden file called Swift version, and Swift Package or SwiftEnv, sorry, looks at that file and switches your Swift to that particular version. So that can be pretty useful. But enough talking. Let's get our hands dirty. So in the demo, I'll create 2 packages. The first one is going to be called mDevTool, and it's going to be providing 2 modules. The first one is just going to be a simple extension on string, which prepends mdev to whatever string you give it. So if we have talk, we'll just get back mDevTalk. Very useful, And the second module is going to be a command line tool that we can, use this tool. And then we'll actually get into some Swift server stuff as well. Okay, so I'm going to try to switch now to Xcode. Okay. So right now I just have a demo folder, and we want to create that first package. So we'll just create a new folder, as I mentioned. The package is just a folder that's called mDevTool. We'll go in there and we'll start writing our code. But right now, there's nothing in there, as expected. The structure I described that SwiftPM requires, you could create it from hand, by hand right now, manually, but it's easier to just generate it, right? So Swift Package Manager allows you to just type Swift package init. And since there are many types of modules, right now we want a library. So SwiftPM tells us what it did. It's creating a library package called mDevTool. It created a package.swift file, a git ignore, which is useful, and then the sources and tests folders. So if we look now, you see the structure I showed you before. This is the basic structure. If we look at here, you can still see that. So this is the package.swift file I showed you. Better? So this is the simple one. And again, you just specify the name of your package, but nothing about the modules, because as long as we're following the conventions, we don't need to. So here, I could write the source code here, but I'm terrible at writing code in Sublime Text. So that would be cool if we could just somehow do this in Xcode. So we can just ask SwiftPM to generate an Xcode project for us by Swift package generate Xcode proj. It just goes through the package, makes sure it understands, and then generates an Xcode project. Cool. I can't type. mDevTool Xcode proj. So we'll open that and actually do our coding in Xcode. Okay, so we have our project. And I'll just go into the sources folder right now and write our extension that I promised you. So we just want to write a simple extension on string, which gives us a public function, public method called mDevified, which just returns a string with mdev prepended to it. Simple enough. Cool, and since we're good developers and we don't want to risk anything, we'll actually write a test for this. So as you can see, all of this was generated by SwiftPM, so that's very nice that you can just jump in and start writing your simple tests. So, it makes it faster. So I want to make sure that my talk gets properly mDevified. That's a weird word. So we want to make sure that the talk turns into mDevTalk, right? Cool. I could just run tests here that would work, but I want to jump back to the command line tool because I don't want to teach you about Xcode, I want to teach you about SwiftPM. So we go back, and here, the command to compile our package, any guesses? No? Swift build. So we just ask Swift to build the package for us. As you can see, it compiled the Swift module mDevTool, which has one source. Cool. And we wrote a test, so we want to Swift test what we wrote. Cool, it compiles that test module and it runs it as well. So you can run this on CI, on continuous integration, and if the return value is 0, you know that all tests compiled and passed. So we can see that we executed one test with 0 failures. Hooray. So we're happy about our package. We just initialize the Git repo, add everything, and just command our first version. Great stuff. We would just push this to GitHub or anywhere else, and in order to allow other developers or ourselves to use this package, you also need a tag, a basic Git tag that makes sense. So here it's a semantic version, just 1.0, simple enough. So right now, once you push this, you have your first package that's usable by other developers. That's awesome. Now, as I mentioned, a library is awesome if you want to integrate it, but if you want to use directly, that's kind of tricky. So let's do one thing. Let's create a command line tool so that we can just call our tool from the command line. As you can see, by default, the sources folder just contains the Swift files for the one module. But here we actually want 2 modules now, so we have to put them into folders, which is another thing that SwiftPM understands, that each folder in sources folder means one module. So our mDevTool will stay the same way. And a new module now, we'll just call it mDev, lowercase. And in order to create a executable module, it needs to have one main.swift file. So as from other languages, the main file is the entry point for the executable. So we just create the main.swift, and all we do here is we just import our package that we created, mDevTool, and all we'll do here, we'll just print the second argument, which is the thing we'll pass to it, and print it mDevified. So we just take the command line, arguments, second one, mDevified. Cool, that's all we'll do. Now, what do you think? Is this going to compile if I do it like this? Well, because I'm asking, it's probably not going to compile. And the reason is that Swift PM is only, smart to a certain point. Right now, since we're using from the mDev module, we're using the mDevTool module, we need to specify explicitly the dependency here. So this is the first time we'll actually go into our package.swift file, and we'll tell Swift PM the specialty here. So we just need to specify that the targets, in our case, just the one target named mDev, has a dependency called mDevTool. Cool. That's all you need to do. So you might notice that we have two modules here, but I'm only writing one. So the thing is, you only need to specify the one that's in any way special. It understands that the second one, the mDevTool, is here and has this source file. So you don't need to specify both. You just specify the one that has the dependency. Cool. So this is the dependency. Now we go and we Swift build again. Cool. It compiled the mDevTool, the library. It compiled our mDev command line tool, and it linked them. Awesome. Let's try to see if it works. So all the Swift PM files are by default saved in .build folder. So that's the hidden folder in your package. So based on the configuration, which was debug, we'll just run our mDev tool, and we'll pass through, let's say, talk. We get back mDevTalk. Awesome. If I put camp here, we get mDev camp. So it works. Awesome. Let's add everything again. Let's comment the second version. Again, we will just push this and tag this as 2.0. And we're happy. We have our command line tool, we have our library. But now I actually want to go further. So we have a library and we have a command line tool, but both things require all our users to run Swift locally. What if you don't want to run Swift locally? What if you're in the browser or something, and you still want to take advantage of our mDevTool library? Well, we'll create a server which will have one API endpoint, and people can just go in the browser and use this. So we'll go back. I actually cheated slightly because I already created that package, but I'll walk you through it. It's called mDev server. It has a lot of things. It has the package.swift file, which I have ready here. And you can see that it's the classic package.swift file and of named mDev server. And here I'm specifying dependencies. So before I was specifying targets, which was the internal to the package, the compilation units. But here I'm talking, hey, pull in external dependencies from somewhere else that I want to use in my code. So that's the dependency in the dependency manager. We say that we want to use Vapor, which is, has anyone of you heard of Vapor? Vapor? Yeah. It's the leading Swift web framework right now. There's about 3 or 4 big ones, but this is my favorite one. It's actually a sticker of Vapor. So yeah. And so we want to pull that in because that will allow us to write a Swift server very quickly. And then we actually can use a local package as well. You can see that the neighbor of our mDev server is mDevTool. So I just go back and use this mDevTool. And I want to use the major version 2, which we have. So these are my dependencies. I also prepared a HTML template, which is just simple HTML, where we'll inject one word under the variable event. So it's something like mustache or any other templating language. In our sources, we just have the main.swift file because we're building a server which is an executable. We import the Vapor framework, our tool that we created that's published somewhere right now, and this is just a special thing to Vapor. So we create a droplet, which is the server handler. We run it afterwards, and we add one endpoint to the get method. And the path is going to be something like, our server /event/talk. We expect that to return an HTML page with mDevTalk. So I want you to pay attention here because this is kind of interesting. This is where Swift as a backend language can actually be much better than the scripting languages or JavaScript or languages that are currently used on the server. Because here, what we're saying is we want to add a new endpoint that starts with the word events, and the second thing is a string. And instead of having to take the request, look at the path, parse it out, look at the last thing, have a lot of rules, we can just say we're expecting a string. So whatever can be converted to string that is passed at the last part of the URL, it will validate it for us and pass it to us right here. So this already is a string. It's type safe. You don't have to worry about that. And we can already use it. So this is one of the big advantages of Swift on the server, because this type safety can really do a lot of things for us and check at the compile time that when we run our server, it's less likely to crash. Cool, so we have our event name. We'll mDevify it properly, as we've done before today. And what we'll do then is just ask Vapor to render our index.leaf, which I showed you here, so it's a basic HTML template. And the event is going to be our mDevified event. Cool, so this is our server. This is our package.swift file. And we'll open Xcode, because again, even for like pretty complex projects, you can just generate an Xcode project. And you can just write your code, write and run your code and test your code in Xcode like you're used to. But you don't have to. You can, but you don't have to. So we'll switch to our mDev server executable. You can see that we have all our source code here. And I'm going to run it. Let's see if it works. Normally it would take about a minute or two to compile, but I already pre-compiled it because I didn't want to wait 2 minutes here. And it's starting to run now. Cool, let's see the log, blah, blah, blah. And you can see that we started a server on localhost at the port 8080. Let's make sure that's the case. We go to localhost, 8080. Boom, we got a 404. But our server is running, awesome. Because we remember that we need events /talk, for example. Cool, welcome to mDevTalk. This is an HTML page that was returned by a Swift server using a library in Swift that we made somewhere, a different place. So this really shows you that, I'll just show you that it's not canned. So camp and hello, you get it, just welcome, just welcome. You can see that in like 10 lines of code here, we wrote a server where we used Swift code that does something interesting, and we can just offer it as a service to people right now. So I definitely encourage you to look into some Swift on the server because, let's be pragmatic. iOS developers or Android developers, we're not the classic backend engineers, but with a big advantage like knowing a very good language that can be used on the backend. If we start learning, we can quickly transfer our knowledge and just use Swift on the server. And maybe, be a full stack engineer and create your own app and everything. Okay, this was for the coding. I'm going to go back to the slides now. Now, we created our package. We created some tests. And what we want to do now is, if we really want to support this for the community or even internally to your company, you should really be doing testing on the server with continuous integration. I cannot emphasize that enough. It really is very easy to do. It's worth it. It's free for open source projects. So really, there's almost no excuse to not do it. As long as you write tests, like we all do, right? You can just, ask a server that someone is hosting for free to just run your tests. And the big advantage here is that if you're actually building cross-platform packages, you don't need to run Linux locally. I mean, you can, it's useful, but if you just have a Mac and you don't want to install a VM or something, you can ensure that your package works on Linux without running Linux. So that's pretty cool. And with something like Travis CI that actually allows testing on multiple platforms, this scales really well. And scaling is important. Excuse me. Because we don't want to have to double our work whenever a new platform is added to Swift, whenever Swift supports more platforms. So with testing on CI, we can just add one more line to test on that extra platform and ensure that we actually support it properly. And as I mentioned, Travis CI is free for open source projects. You can see an example again in the environment. This is a link, as I mentioned. And this is an example of the whole Travis YAML file. So this is all you need to do. If you want to test on Travis, you just add a file something like this to your project, and then you go to travis.org for open source projects, and you just just enable it there, and that's it. And it just picks up this file, and it knows what to do. It runs your tests. So in our case here, at the top, I want you to see that we have two OSs. So we have Linux and OS 10. So they actually support multiple different images, and when they add maybe some new ones, the extra work for you to support Windows, once that happens, will be just add one line and then actually see if your package runs on Windows. This script here is the thing that actually installs the right Swift, but if you specify Xcode 8 here, you don't do that anymore. Because, as I mentioned, Xcode 8 already contains Swift Package Manager. So all you do is call Swift build, Swift test. If all that succeeds, we're done. Sorry. So we create our package. We really like it. It's being used maybe by some people. It's being tested. Our README, when it says works on Linux, it actually works on Linux. And how do people discover it, and how do we discover other people's code? So there's the established routes, like CocoaPods search, which is an amazing tool. If you don't use it, definitely try. Even if you don't use CocoaPods, this is a great way to discover new projects, because they have these scores that are really well made, and usually the first result is a very good package maintained and usually working. But there are new ways now with Swift Package Manager. There's the Swift Package Catalog, which is actually created by IBM. Yes, IBM is doing a lot of open source Swift. You should take a look at that as well. It's awesome. They're putting millions, or maybe hopefully in the future billions of dollars into making Swift viable on the server and everywhere else. So the Swift Package Catalog is just for Swift packages. The libraries.io is for a lot of different package managers, and also they added Swift PM recently. And I wouldn't underestimate just spreading your work on Twitter and GitHub, just organically. So it really works well for me. So when I create some package and then I just tweet one line, something like Charles said, you have to figure out what that one line, the elevator pitch for your package is, like, prepends mdev to your string. Perfect. Just tweet that, tweet the link to GitHub, and then see. And people maybe will like it, retweet it and stuff. And it can actually spread naturally like that, even better than maybe putting it on central indexes. But this is more like a list of things you should do. Just make sure that your work is on all of these places. And as I mentioned, the server-side Swift community, I use Vapor, which is created by a little company or two guys called Q3. Then there's IBM doing a lot of open source Swift. They have their own Swift server. Then there's Jeho, another group. They also have a web framework. And there's OpenSwift, which was created by Jeho and Vapor initially, and now is more people where they create standards. So if you write, so basically something like standard HTTP request struct. So instead of when you're switching from Vapor to Jeho, instead of having to rewrite everything, if you're using these standards, OpenSwift types, then it should be much easier. And there are more. There's like Perfect, and there's other groups, but this is just some starting places. So as I promised, let's dive a bit more into advanced packaging here. Swift Package Manager has Swift in the name, but that's kind of a red herring because it in fact supports more languages. It supports Swift, and it supports C, Objective-C, C++, and Objective-C++ right now. And there's not really a reason why it can't in the future support like C# or other C variants. And what's kind of cool is that with Swift Package Manager, you can actually create C libraries as well. So I did that with forking zlib when I wanted to add a gzip support to one Swift server. So I just had a pure C package used by the Swift package manager. So Swift package manager really means Swift C Objective-C package manager. It really works for all of them. And as we saw in the demo, there's multiple commands. There's not one like Swift PM command. That really.
So this is kind of weird, I have to admit.
That it's a Swift build, not Swift PM build, or something like that. But Applu really wants to keep these, in the Swift namespace. So if you type Swift, all of these things come up, including build, test, package, and stuff. So they didn't want to do the Swift PM command at all. So what it ends up being is that Swift PM is really 3 commands. It's not just one. Swift build, as you would expect, just builds your package. You can pass through some flags and things you would expect. It has a pretty good output, but it just builds your project. In addition to pulling your dependencies. So it really starts
by looking at your packages Swift file.
It looks.
If it sees all that code you're saying that is somewhere, and then looks at dependencies and just
goes one by one and downloads those dependencies into a packages folder. So that's how it gets the dependencies first. And once that is ready, then it starts building all those dependencies and linking them, and you're basically putting the products together. So that's all that Swift build does. It does downloading dependencies, compiling your code. Swift test
compiles your test targets
and runs your tests. So it does these 2 things. And you can actually do some interesting things. You can just run one test with the S specifier. So that feeling when you have like 1,000 tests, but one is failing, and you just run that one over and over again until you get it working. That option S is very useful for that. So you just give it a minimum 1 test, and you can just run that from the command line. And that's pretty much all that's interesting on that. And you can also list tests, which might be useful if you're building some tooling around Swift Package Manager. If you want to get like a list of tests and show, I don't know, generates like a JUnit output or something like that, it might be useful. But the catch-all for all of them is Swift Package. That's where the interesting stuff is. So as we saw, init command is here. Which just generates those files that you need for special for type of a module. It can just fetch, it can update, it can generate the Xcode project, which we already did. And there's some cool stuff like show dependencies. So here, show dependencies. So what it does is actually it goes through the dependency tree and it renders it as text. But it has options to output that dependency tree as JSON or dot, which is a graphing format. And then it can actually dump a package.
So this one I actually added to Swift PM.
And this one was useful because I was building some tools that parsed the Swift package. So this option parses the package, the Swift file, and outputs it as JSON. So just not to have to parse Swift code. It actually can do that for you. So again, I talked about package, as a thing that is useful for you when you're writing code. But if we look at what packages internally to Swift PM, it really is just a collection of modules. So I keep talking about these modules and packages, right? So a package is just a collection of modules, and one module is just a collection of source files with some instructions of how to build that. So each module gives you one library or one executable. And a package has one or many of these modules inside of it. As I mentioned, there are multiple module types. So as we saw, the library one, which just compiles a library. An executable, which needs strictly one main.swift file in it, and SwiftPM understands that that means, hey, SwiftPM build me an executable, and their system module. So the system module is an interesting one, because you know that on a lot of our computers, there's a lot of compiled C libraries, like OpenSSL, on Linux, for example, but OpenSSL example. So it's compiled there and has some headers. The question is, how do you
pull this into Swift Package Manager?
Because you don't have the source code for it, it's compiled there. So it's the module thing that bridges compiled C libraries into Swift. So it's actually very, very useful. So it lets you, on your computer,
just pull in
the OpenSSL or libcurl into Swift, which are already compiled, already present libraries. It uses module maps, which are files. This is part of LLVM, really, the compiler. And you just basically say, hey, I want Swift to see a module. It's called cmongoC. And the header is at this path, and please link this compiled library. And exporting is not going here. So this allows us to really use things like OpenSSL and libcurl in Swift without compiling it, because it's already there on the system compiled. If you are interested in that, check out these two articles from Ankit, who now actually works for Apple. And he wrote extensively about how to get this working, so he has very good tutorials on that. If we go back to modules that I mentioned, there are sort of two ways to specify modules, right? There's the implicit way, by just structuring your code this way. So here it understands that we're expecting two modules, an mDevTool module and an mDev module. And that the mDev module should be an executable, and the mDevTool module should just be a library. And then here in tests, we have an mDevTool tests, which is a test module. But you can also explicitly specify things. And we needed that during the demo to specify the relation,
the dependency
graph here. So we just said, hey, explicitly I'm saying in our package.swift file, mDev needs mDevTool. So there are sort of two ways, and they usually complement each other. So you just want to use explicit if you can't implicitly tell SwiftPM. Again, as I mentioned, SwiftPM is a
Swift dependency manager, really.
So the dependencies, as we saw, you specify by adding
the dependencies key and
just giving it the package structure. And you give it the URL, which can be remote or even local, and you just give it some version constraints. Now this is going to get more interesting, because as I mentioned, the show dependency command in SwiftPM shows you something like this. So it looks like a lot of text, but if you look at the top, this is I just call Swift package show dependencies for the mDev server, and it shows me that Vapor, that's one of our dependencies, is at this URL, and we're using version 1.02. And then Vapor has dependencies of crypto, Fluent, Engine, Console, JSON, which in turn, so you see recursively crawled dependency tree here, which I haven't seen for that many other tools, and this can be so useful when you're figuring out if you're upgrading one module really deep, what it's going to affect. So this can be really useful. And I want to take it further, so I actually built this service, which runs on the Swift server, obviously. And what it does is you just specify a GitHub name at the top. You just give it a Vapor, which is a project. You ask for the PNG graph, and it just goes and generates that image for you. So this really should help you understand, hey, I'm using Vapor, and someone removed the Vapor path indexable project from GitHub. So at least you know that you need to fix Node, then you need to update Fluent and Leaf, and then you need to update Vapor. So when you're updating, these graphs could really help you out. They help me quite a lot. I'm already not maintaining this anymore, because as mentioned, I'm going to Apple, so I can't maintain this anymore.
But this URL is still
forwarded. So if you just go there, you can forward it to the new server that's maintained by a friend of mine. So SwiftPM really is a lot of things. It's pretty young. It's not even 1 year old, and it already has a lot of features. It is really useful, and it enabled quite a lot of communities to start building things in Swift. But the way it changes really is pretty cool. That's the classic Swift evolution process. So if you haven't heard of the Swift evolution process, that's how the community can actually be included in the process of developing Swift. So the Swift application process is a way where you can create a proposal for a change in Swift, and then it gets reviewed, and if it gets accepted, then your change is going to be accepted in Swift, and the next version of Swift is going to have it. So the same thing for Swift PM. And Swift PM really is the result of these proposals. So again, these are links. You should probably start, if you're interested, at the community proposal, which is sort of the founding proposal, and then all of these added the specific features. And these are proposals. So these propose the solution, and then the implementation happens later on, once the community and Apple people together decide, yeah, this is a cool thing to add. But of course, it's pretty young still, so it does have missing features. Big one is much more deeper Xcode integration. So it would be nice if you could just open an Xcode project and call Swift PM from Xcode. That's not possible right now. Definitely better iOS, watchOS, TVO support. So right now I would only recommend using Swift PM if you're building Linux projects, like command line tools, or macOS libraries or command line tools. Not yet really for iOS projects. I've hacked it together before, but it's better if you just wait for better support. And the next thing is, you tell me, because the beautiful thing about the new Apple is that they're much more open. They're much more pulling people in into their company for one thing, because they found a lot of people that are being hired right now in the open source community. That happened to me as well. They found me through open source, and many more people are joining as well. So that's the cool thing, if you're interested, definitely read these proposals, join the mailing lists, and just get involved. If you're interested in contributing to the Swift project in general, which is the compiler, the standard libraries, Swift package manager, foundation, XC tests, and everything, watch this talk by Jesse Squires from TrySwift. It's a very good talk. He basically just outlines, if you're interested in compilers, which project to check out.
If you're interested in just, the standard library, where to go. So if you're interested, start there. And I recommend that you do, get involved, because it's a great way to learn, and it's a great way to motivate. What do you know? Maybe you'll come up with this cool idea for Swift. You just tell a couple people, you discuss it in the mailing list. 2 months later, it's in the official Swift standards, and it's in the language. And I've seen a lot of people not very interested, but then gradually getting interested, and now they have multiple proposals that have been accepted. So it's not that difficult, and if you're interested, it's interested a lot. So yeah, starting the mailing list. Look at the documentation and look at the source code, because we're all learning Swift still. Swift is pretty young, so it's good to look at some consistent code base, like the Swift package itself, or the Swift libraries, where you see how people inside of Apple are writing Swift. And this is the first time you can actually look at that. Join the Slack, which is good if you just ping people. If you're looking for help, they can really help you. There's about 100 people now, and it's growing slowly. So join as well. And follow people that do this stuff. I cannot emphasize that enough again, how much stuff I've just found myself through following the right people, and people that are interested in this stuff. Okay, and that's it for me. Thank you very much for listening.
Okay, thank you for the talk, and now we can proceed to the questions. So, can you share your Sublime text configuration plugins?
I can actually. It's the material design. It's sort of actually a friend of mine recommended that one to me. So I can do that. I'll tweet it today. I'll try to tweet a link to it. It's material design, so if you just go to the Sublime text, install package, and you just look for material design, it should come up. It's just the standard material design theme. It's nice, I agree.
Perfect. Thank you very much. So next question: does Swift package manager allow
to add example project as
CocoaPods?
this, I'm not sure I understand. Do you mean like adding an extra module inside of it and saying this is an example and having some extra support, or can you maybe elaborate on the question? Klidně v češtině může být. Okay.
In CocoaPods, you have an example project. You download the repository and you can run it and see what it does.
You mean like pod try? Is that the one?
I mean an actual app.
Okay. You mean like each project has one example inside of it?
Yes.
Okay. So there's no support specifically for that in Swift PM. I actually do that. So I usually just have library for J,
and then I have J example, which is just an executable
which you run, and it just shows you sort of how to use it, and it's just a sanity check. But that actually becomes a problem. People that use your package also compile it, so it starts growing, and there's a proposal that hasn't been accepted yet for sort of doing private modules and public modules. So you could have an example which is a private module, and then you just say this is an example, but if someone pulls in your package, it's not going to get compiled in their project, which is just as slow.
So not right now,
but it's interesting. I think that would be a good idea for a new mailing list thread, maybe a new proposal. So you should try it. You should definitely just bring it up, be like, pitch, in the mailing list, like, hey, here's a pitch. I think it would be cool to support something like this. And you'll see people will respond, and maybe you can turn it into a proposal.
Okay, so next is the off-topic question. Could you compare studying at King's College and FEL?
Yeah, sure. So I can compare to a certain extent because I studied for 3 years at FEL, and then I studied for 1 year at King's College, and one was bachelor's and one was master's. So for as much as I can compare, I really liked both. I have to say I really liked both. I really enjoyed my time at FEL. Cybernetics Robotics was a really good program, I felt. And there was sometimes certain subjects that I didn't feel were that important, that they were they insisted were important. So of course, every school has a little bit of bullshit. So the question is, how much was the percentage of that? How much of this stuff you don't want to learn, how much is actually useful? And I would probably say that King's had slightly a higher percentage of the stuff that was very interesting and it was very useful. But I want to actually provide some specific examples because this is very vague. So I feel at FEL, we had to do a lot of practicals, cvičení. Like when we actually go and we have to do examples and they get marked, and we had these little tests and stuff. So throughout the year they try to sort of make sure you're learning. At King's they didn't care. I mean, the only thing that they tested was at the end of the year or the end of the semester we had 1 3-hour exam that was written and then they marked it, and that was all. So throughout the year if you didn't study, that was your problem, but no one cared. Whereas it fell in a lot of classes, you had to do tests, you had to do homework and stuff. But I would probably say that it's better to do homework and tests because you just learn throughout the year instead of panicking towards the end of the year. So that's probably one example where they expected us to be much more independent, but then it comes for a price, with a price that you have to study for that exam a lot. Otherwise, you just fail it and you have to retake it or they kick you out. But I can definitely, the after party, just come to me. I can talk about more examples. I just can't come up with any more right now.
Okay, so next question seems like from my friend Jan again. In your opinion, what's the future of Objective-C?
That's a very, very good question.
Good question, Jan.
Well,
what I think about the future of Objective-C, that's all I can share
right now, is it's not going anywhere. And a big reason is internally to Apple, it's used extensively. I've heard. My NDA is starting on Monday, so whatever I say today, I didn't break any contract yet. Okay. So I just heard that they use Objective-C still heavily, and what they just support gradually is the support of Swift, Swift calling into Objective-C, but they didn't rewrite, or they're not planning to rewrite frameworks. So Objective-C is here to stay, and if you know Objective-C, that's awesome. Different question, if this is your first language and you're going into iOS development, should you learn Objective-C? No, absolutely not. If it's a new language that you don't know, don't learn Objective-C. Just go all in on Swift, and that is going to take you very far. You don't really need to know that unless you go into a company that has a big code base in Objective-C. But I think we saw in the last about year or two after Swift was announced that there are still improvements coming to Objective-C, like Objective-C generics, the nullability, and a couple of new things that improve compatibility of Swift and Objective-C together, but also improve Objective-C. So I think if it's not too much work for them, they'll improve Objective-C gradually with Swift, while they can. So I think it's still going to be developed, but when it comes to should you invest your time into it, I think not as much as to Swift anymore. I'm not sure if I answered the question.
Okay, so could you share your slides? I already know the answer.
Yeah, I already did. So if you go on Twitter and you go to Chickboy0, which is my Chickboy0, those are the slides. The slides are already here as well, which is kind of a paradox because you cannot click on this because that's the slides you're trying to get. But if you want to type it out, I should have probably done bit.ly or something. Just go to Chickboy0 or to honzadvorský.com, and on the main page you can see the link to it. So yeah, Twitter, website.
So is it possible to use Swift Package Manager in the playground?
I don't think so right now. That would be an excellent proposal. Again, who's asked that question? I can look at you. I think that's a good proposal. Would be a good proposal because there are some hacks of compiling your stuff with Swift PM and then dragging things over and maybe hacking that a bit. But I don't think there's a nice way to just be hey, Swift PM generate the playground instead of generating an Xcode project. But on that note, what you could do is generate the Xcode project, and inside of the Xcode project, create a new playground. And if it's in the same project, you can actually import the modules that are compiled without a problem. So not directly, definitely bring it up on the mailing list as well. I think that would be a good new feature. Just generate playground instead of generate Xcode project, but you can sort of do it through the Xcode project, I think.
So last question, I never try coding in Swift. I would like to try. Is it a good idea to use the Swift Package Manager too?
It really depends on the context. Who asked that question? Sorry. Yeah. It depends on the context. So if you want to do iOS development and you want to learn Swift, I don't think you need Swift PM right now. But if you, for example, are interested in the Swift on server, that would be definitely something you would want to use because that's how we would pull in the dependencies, and really that's the easiest way to do that right now. So if you just want to learn Swift, download the ebook from Apple on Swift so that will just take you through it. My dad started learning Swift 2 months ago, and but then if you actually want to start building little projects, I think Swift PM is a good way to do it, and especially if you want to try to build a server, which really, you saw, that's 10 lines of code. Do something easy. I wanted to do something easy, like prefix a string, but if you have something more complicated, you can put it on the server this easily. So yeah, I would say if it's for the servers, yes. If it's just iOS, maybe not, but it can't hurt. It's part of Swift now, so you just type Swift on the command line, you have it there if you want to use it.
Okay, so there's another one. Package.swift is obviously a Swift file. So you have encountered any weird practice in this file?
I'm not sure if it's weird. It's actually better. I think in a lot of ways it's better than JSON manifests. For one thing, you can add comments. So that's a big one. So you can just say, if you have a lot of dependencies, we're using this for the server, we're using this for some weird parsing, so you can annotate better. It's a Swift file, so you can do if-defs. So you can just say, hey, if this package manifest is being parsed on Linux, pull this package. If it's being parsed on Mac OS, pull this other package. So you can do much cooler things, like compile time constants and stuff, and compile time decisions of what you're actually pulling in, and it's just Swift code. So technically, it's not very safe. I've been discussing with some people on the Swift PM team that maybe it should be run in a sandbox, because technically, you could inject some Swift code, some malicious code, and then someone pulls in your project, and you can actually run on their system. So be careful with that. Make sure that you take a look at the packages you're using, and you trust them, and that you're pulling everything over HTTPS. I mean, that's the bare minimum. But yeah, just be slightly careful, because it's executable code that you're pulling in and running on your computer that someone else wrote. But
Since it's a Swift file, the Xcode will not suggest you anything, so it's it's a safe feature. Okay, so I think we run out of the questions. So again, I would like to applause for Jan for the great talk.
Thank you.